So if you've looked around for information on how to build sequencers in Max MSP, maybe you found this book, Step by Step, Adventures in Sequencing with Max MSP by Gregory Taylor. This book is great. Definitely recommend buying it if you don't have it already. And certainly, if I can't convince you, then perhaps Sean Booth and Dennis DeSantis can. And this book is basically a sort of step-by-step guide to building sequencers in Max. And it makes very heavy use of this object live.step that you can see here in the book, and whose help patch I also have open here in front of me. What makes this object great is that it puts all of the basic UI elements from pitch control, velocity, duration, and a bunch of other stuff into one object, and then actually even allows you to drive the sequencer from within the object. Like this. Now, I've never really used, I've used it a little bit, but I haven't used it lately and haven't seen any videos in this channel. And that's because the kind of approach to sequencing that I've been taking is rooted in signals and really came from Max 8.3, the introduction of a handful of objects like subdiv and what that allow us to use a phaser as our basic source of time and work with the sequencer in the signal domain, which has all kinds of benefits. And if you don't know what those are, I can point you to some videos. I'll put some links down in the description below. But the downside to that approach, I guess, is that this awesome object live.step doesn't really work with it, because this object basically expects you to send it events of some kind. In this case, it's getting this like time value, which is kind of cool. Which in a way is actually a little bit like a phaser. It's like an event-based phaser. You can also send it like a step index. There's a lot of different ways that it works. But obviously this is still not a signal. So someone in the Discord asked, hey, well, how can I get these two things working together? And I thought it was a great idea for a video, because it would be a shame to sort of waste such an awesome object when it's available to us. So this video, I'm going to basically go through my method for how I would get this live.step object working with a sequencer that is built with objects like phaser and subdiv and what, as well as rhythm and time toolkit objects, which is the Max package that I made for sequencing with signals in Max. So I'm just going to show you that patch in action, and then we'll start from scratch and rebuild it. So what I'm doing here is sending MIDI to live, where I have chiral from 4 is running. And basically we have a live.step that is not actually connected. The output, which is here, is not actually connected to anything. What we're doing instead is basically just using it as a UI. We're using it to populate lots of parameters, to set parameters. We're storing those in a buffer, which is this one called sequence here. And I'm displaying the contents of that buffer here. And then we're just playing the contents of that buffer back using these index tilde objects. And then we're using rtt.makeNote from Rhythm and Time Toolkit to turn that into MIDI. A little bit out of tune, but you get the idea. Okay, so let's start from scratch and build this thing. Okay, so let's just copy this live.step that we already have here. I'm gonna make this big. And basically what we can do is send a dump message to this object. And if I print the output, you can see we're getting a bunch of lists, one for each step in the sequence, with the pitch, velocity, duration, and the auxiliary data. So the sequencer has the ability to store pitch, velocity, duration, and then these 2 extra lanes that can be used for anything that you want to use them for, like you could send a CC or something. And so what we're going to do basically is have a buffer that has multiple channels, one for velocity, one for pitch, one for velocity, so on and so forth. And then each of the sample slots within the buffer will store these kind of columns of data. All right, so I'm going to create a buffer. I'm going to give it a name. Here I'm going to use this #0 underscore syntax, which basically makes it so that this buffer is visible only within this patch, which is useful. So if you have, maybe you'll have multiple instances of these, you can kind of keep them separate from one another. And then, so now we have this, and actually I need to initialize the sort of size of it. So the arguments of buffer basically are, the first one's the name, the next one is the length in milliseconds, I believe, which doesn't really matter to us right now, and I'll show you why. The next one's going to be the number of channels, which is going to be 5, because there's 5 elements that we need to store in it. And then the last one, we're going to actually override the length that's set in milliseconds here and actually use a number in samples. And we'll say 64. So what this means is that the maximum pattern length is going to be 64 steps. And then at the output here, we'll say route step, so that we can just get rid of that first bit. And here at the top, we're going to make sure that we clear our buffer before we do anything. So actually, I'll do it like this: tdump clear. Oops. And a bang. So anytime this bang is banged, basically what we're going to do is get the contents of the live.step in this format that we see over here in the print, which you cannot entirely see. There we go. And then store it in the buffer. So we're going to store it using a poke object. So we need to give that a name. So this poke object is how we get things into a buffer using messages, actually, or signals. And it has 3 inlets. So the first one is the sample value we want to write. So the number that we're actually going to put into the buffer. The second is the sample index. So the kind of x-axis position, the slot. So out of these 64, which of those 64 positions are we going to store that value? And then the third is the channel, so the sort of the y-axis position, because we can think of this buffer as being kind of like a 2-dimensional matrix, or a table that has 5 rows and 64 columns. So you could think about this poke object as inserting data into this table, the first inlet being the data to write, the second being the x-axis position, and the third being the y-axis position. So the step is going to be the x-axis position. So what I'm going to do is actually use zeal esils to first flip this list around and get just the position. So if I print the output here, you'll see, oops. What did I do wrong? Oh, I needed to reverse it first. So I'm going to reverse it and then use zeal esils, because what I want to do is actually get the slot, the x-axis position first, and we're going to put that in here. And then I'm going to use list funnel, and I'll reverse it back. Then use list funnel, and then zlnth2, which is a nice convenient way to both reverse a list and unpack it. So here we have this step list. We're going to reverse it around. We're going to use ZL easels to take the rightmost value from it, which is going to be the step number. So if I just print one example here, so the 16, then we'll reverse it back so that things are back in the normal order, starting with 62 here. Then we'll use list funnel, which is going to give us a 0, 62, 1, 103 to 120 as separate messages. And then we'll unpack each of those so that we get the index of the position of the item in that resulting list, which will look like this. And you can see if we print that result, it's like that: 0, 60, 1, 101, 2, 120, 3, 127, 4, 127. So the right outlet, which comes out first, which is important that it comes out first, is going to be the channel. We need to add 1 to that because for poke, for whatever reason, it likes to start channel counts from 1. And then the final thing will be the actual value here. So now if we dump this again, it should be that we actually see some data in this sequence, which we do. So this isn't very helpful because, or the view here isn't very helpful because by default, these kind of buffer viewers work on a -1 to 1 range, whereas our values are on a 0 to 127 range. So what I'm going to do is create a waveform object. I'm going to use a buffer name of sequence with the 0 pound stuff 4. And then I'm going to say vzoom is 127 and voffset is 1. And what that's going to basically do is change this. Actually, I think it's vzoom 64, actually. It's a little bit weird how this works. There we go. So now this waveform object is showing us the contents of the first channel of this buffer on the range of 0 to 127. So this is going to be the pitch. And then if I duplicate this and I go into the inspector, I can select the channel. So now this is the velocity. And then we'll just do the duration. We'll ignore the aux for now. Duration. Cool. So now we have stored the contents of this live.step into a buffer, and now we basically just need to have the ability to look up those values inside of a in our signal-based sequencer. And I'm going to build a really simple one. So rtt.clock at BPM, let's say 60 with a toggle. I'm going to use subdiv 16. And I'm going to use index tilde and this is the object that's going to look up values in the buffer. I'm going to start with the buffer name, and then I will give the channel. So if we get this thing running, we should now see it's going to look up the values in the pitch list, and that does seem to be working. So then we can simply duplicate this index for the second channel, which is velocity. Kind of squeezed for space here. Oops. And the duration. Maybe I'll stack these like this. Give myself a little room. Okay. So those are our velocities, and then these are our durations, which are constant. Then what we can do is simply just, if we wanted to like generate some MIDI, we could just do rtt.makeNote, which if you want this object and you don't have Rhythm and Time Toolkit, the way to get that is to go into the package manager, search for Rhythm and Time Toolkit, and install that. And then you'll have this object. which is very handy because it will basically convert these three signals for pitch, velocity, and duration into MIDI notes. But we will need to trigger it. So this object, it's going to receive these, but we need to actually tell it, hey, when's the event actually occur? And we can do that by generating an impulse from using what from the first outlet of subdiv, which is producing a phasor. So this phasor gets transformed into an impulse. The second outlet of subdiv is a counter, basically counting how many, or kind of what index it's on. So when we generate that impulse, I'm going to now make a MIDI out, and I'm going to target that to live. And there we go. So we're pretty close. A couple other things that I want to do here. So one is make a visualizer so that we can actually see the sequencer as it advances. So I'm going to use a snapshot. And I'll use change here. I think that should be all we need. Oops, but I need this. Oh, actually, do we get it as... Ooh, we get this float number as an int. So we don't even... Step number as an int, so we don't even need that. There we go. That was easy. Although, it seems that live.step wants things to start from 1. And it appears that we may have another issue. Because it seems like there's a pause at the end. Here we get MIDI note 0 at step 1. It appears I need to subtract 1 here. Which makes sense because the step counting starts from 1 from live.step, so I need to start it from 0 before I put it into my buffer. And by the way, I can kind of clean up my patch here. Instead of adding 1 there, I can just tell list1 will start your counting from 1. So that has the same effect. So it's a little confusing. The buffer channel starts from 1, the buffer sample slot starts from 0, but the live.step starts from 1 with the steps, which are the sample slots. So we just have to make sure we handle all that correctly. So now that should work if I dump. There we go. So that's that. The only real other thing to do here is if I change this, it's not automatically going to fill the buffer. I still have to click this button. So let's add some capability that allows us to do that. Now, live.step does have this handy feature, which is that it will report like hover events. So if you mouse over, it will tell you. But the thing is, it's going to output a lot of messages just anytime I'm hovering. And I don't want it to like constantly be banging the dump and constantly refilling the buffer just when I'm like hovering over. I want it to only happen when I change. So what we can do here is use the mouse state object, which will report when the button is pressed down. So now basically what I'm doing is these, what's interesting too is, so like this mouse state object, if you create it, mouse state, and you do the toggle, and I just start clicking, this one's not going to produce anything, but once I bang it, then it will. So I think what we should do is just do a load bang to initialize it. And then we'll like store this state. And then we'll turn this into a bang. And we may also want to do like a delay object here. So like a delay 200. So basically that the maximum frequency with which this resampling or redumping can occur is 200 milliseconds, and then wrap that around. Oh, and we need a cell 1 here. So we'll store a 1 here. Basically, every time the mouse is on, there's a 1 that's going to be stored here. We'll get a bang reporting this mouse over information from live.step, and it will cause this int object to output whatever value is in there. If that value is 1, then we're going to trigger a bang, and we'll only ever send out bangs every 200 milliseconds or less often than that to trigger the dumping. And you could set this to whatever you want, 250, whatever. So let's test that now. Seems like it's working. Cool. So that's basically it. Let me go back to my other patch where things are a little bit more detailed and commented. So the only real differences in this one are I encapsulated these pieces here that are doing the filling of the buffer as well as the mouse detection stuff. This is a little bit nicer looking, and we're also showing the auxiliary lanes. I'm not doing anything with those, and I'm also querying them here. We're not doing anything with them, but you obviously could. You could use rtt.makecc to send them out as MIDI control change messages or what have you. Of course, if you are using an instrument that's based in Max, like the sampler that I did some videos on, that is triggered usually by an impulse, then this stuff is all going to be pretty much ready to go to use with that. And obviously you can use the pitch values and things like that with objects like rtt.scala, which allows you to lock those pitch values to a scale, so on and so forth. So yeah, I believe that's it. Oh, one note to add. So live.step has a pretty cool feature, which is that you can actually store multiple sequences in it, and you can play them back at one time. Or maybe you can't play them all back at one time. I can't remember. Maybe you can only play them back separately. But anyway, we're not really working with that functionality. Like this buffer only has one sequence inside of it. So you may need to add, if you use this kind of multiple sequence capability that live.step has, you may need to add some extra patching to be able to make sure that whatever the active sequencer is the one that's actually living inside of the buffer, which shouldn't be too hard. You just have to bang the dump button when the active sequencer changes, basically. All right. Let me know if you have any questions, and I'll see you next time. Bye-bye.